Okay. Okay, guys, thanks for coming. Let's do a review of exam 2, unless you have questions for me first. Do you? Okay, so starting at the very beginning, we started with empirical rule and Chebyshev, remember? So those two topics are still on your exam. Empirical rule, can anyone tell me what is the empirical rule? What is it used for? What is it? Can you tell me? Yeah.
I forget the numbers, but it's like 99% like within 3 standard deviations.
Right. So the numbers are 68%, 95%, 99.7% for 1 standard deviation, 2 standard deviations, and 3 standard deviations from the mean. It's only good for mound-shaped data. I'm going to scan these notes when I get home, so you'll have a copy if you don't want to take notes. Okay, so a question such as this: find the approximate percentage of data outside of 2 standard deviations from the mean. So it's mound-shaped. So 2 standard deviations is just here. So the answer is 5% because we're talking about this plus that. What about something that's mound-shaped and I want the percentage of data from 1 standard deviation to the left of the mean to 3 standard deviations to the right of the mean? Yeah, of course. Yeah, just keep telling me and I'll keep moving it. So 1 standard deviation to the left, so this is mu minus 1 sigma and mu plus 3 sigma. So this would be 34% because it's half of 68, and then the percent. Agree? Because this is half the curve. Basically, it's half of 99.7% plus another 34%. So we're talking about 84%. And in reality, it becomes 0.8413 if we're talking about a normal distribution. Agreed? So that's empirical. It's not that complicated. The next one is Chebyshev. Chebyshev is used for any distribution. It talks about the minimum percentage of data within k standard deviations of the mean. So it's good for any distribution at all. Start at the mean and go k standard deviations on both sides of the mean. So let's say k is 2.5. That means I went 1, 2.5 standard deviations on this side, 1, 2.5 standard deviations on the other side. And the minimum percentage of data within is equal to 1 minus 1 over k squared. So for me, it's 1 minus 1 over 2.5 squared. So I like fractions, so it's 1 minus 1 over 2.5 square. 1 minus 1 over 5 halves square. 1 minus 1 over 25 over 4. So that would be 1 minus 4 over 25, which is 21 over 25, which is 84% minimum. That's within, right? If I want the stuff outside, then it's going to be maximum 1 over k squared outside. So this and this add up to 1. So this is 1 over 2.5 square outside. Maximum. And you can't split them. You can't split that and say half of it on one side and half of it on the other side. It doesn't work that way for Chebyshev. It only works that way for empirical rule because we're assuming symmetry and mound, of course. But there's no symmetry assumed here, so that's it. Any questions on each of these? Yeah.
Can you explain the first one again that you did?
Any particular thing that you want me to elaborate?
I don't really understand how you got the 84%.
So I got the 84 by going, this is half the curve, so it's 50, this side. And this one is half of 68 because this rule right here says that if you take a mound-shaped distribution and you go one this way and one this way, then from here to here is 68. So this is 34 and this is 34. So half of this is 34. I only took the 1/2. Get it? Okay, what other questions on this? Yeah.
Can you explain the other part?
Chebyshev?
I got 0.05. Because I thought only the end would be 0.05, not the whole graph.
So it's saying that from here to here is 0.95. So this plus this is 1 minus 0.95, which is 0.05. Get it? Okay. Anything else? Yeah. I made it up. So the question said, find the minimum percent of data with 2.5 standard deviations from the mean. That part was given in the question. Any other question? Yeah.
Will it ever be more than 3 standard deviation for Chebyshev?
Yeah, it can be.
Oh.
So suppose it's 3 1/4, right? So you would go like this. K equals 3 1/4. So this is 13 over 4. Therefore, 1 minus 1 over 13 over 4 square, like that. So that's 1 minus 16 over 169. So it's 153 over 169. Minimum lies within 3 1/4 standard deviations from the mean. Get it? Okay. What else about these two things? This was on the previous test. So it's going to be on this test again. Yeah.
This is stupid, but when you're dealing with fractions, how did you know to flip?
So if I want to do 1 divided by a over b, that's b over a. Because if I'm multiplying the top by b over a and the bottom by b over a, that would make this cancel, and that's how I get b over a times 1. That's why it flips.
Okay.
Get it? Okay. So after that, we started the new material. So let me just label these pages. The new material was on continuous distributions. So the first thing we started with was a distribution that's linear, something like this. Let's say y equals x over 5 from 0 to some point b, such that the whole area between 0 and b is 1, right? And the question says, find the probability that x lies between 0 and 1/2. Or the question says, find the probability that 1/2 is less than x is less than 1, let's say, or 1.2, let's say. So the whole thing to realize here is that area is equal to probability. So probability equals area. So here I'm looking for the area between 0 and 0.5, and here between 0.5 and 1.2. So there are many ways to do this problem. One way is to do it on your calculator by putting it into, let me just grab my calculator and I'll do it. So I can go to y equals and put in some function x over 5, let's say. And then second calc integral of f of x dx from, it's going to ask me the lower limit, I say 0, and then it asks me the upper limit, so I'm going to say 1/2. And then it shades it and gives me the answer, 0.025. Get it? So I could do that on the calculator. Y equals, put the function in, x over 5. Here, this is where you find the x, right? Right there. And you might want to adjust the window. Adjust the window if you had to. And this is where the window is right here. And then second calc integral f of x dx. And then it says lower limit equals 0 and upper limit equals 0.5. And then it spits out the answer, which is 0.025. That's one way to do this problem. The next way to do this problem is to just integrate. So integral of x over 5 dx from 0 to 0.5. So this is equal to x squared over 10 from 0 to 0.5, which is equal to 1/2 squared over 10 minus 0 over 10. So I get 1 over 40, which is 0.025. Same answer. That's the second way to do that problem, right? Is to just go ahead and integrate. If you don't know how to integrate, just ignore me, okay? It's not that important. And 3 is by geometry. So I'm asking you for the area between 0 and 0.5. This area. So 1/2 times the base. The base is 1/2 right here. It's the base. Times the height. So the height is the function's value at 1/2. X over 5. So 0.5 over 5, which is 0.1. So I get 0.1 over 4, which is the same as 1 over 40. So the answer is still 0.025. Same answer. Follow me?
You say your upper limit and your lower limit is 0 and 0.5.
These are these. It's in the question. That's the question. It was given. Everybody okay with this? Yeah. Go ahead, love. Yeah. Okay, yeah, I'll do the other one, right? So if I was doing a new problem, I would start here at y equals. Put the function in, x divided by 5. Then you go to second calc, go all the way down to number 7, which is integral of f of x dx. Lower limit, I'm here, right? Lower limit is 1/2, 0.5. Enter. Upper limit, 1.2. it shades it, and it spits out the answer of 0.119 on the calculator. Get it?
Should you do it on a CI-84? The
Same.
graphing part?
Same thing. Bring it over. Let's see, hopefully. Okay, so this is good. So first of all, the window is a little off. So may I change your window?
Yes.
So window, you see this X min minus 4.7? That's not helpful because your X min starts at 0, right?
Okay.
That's good enough. So then we'll just say graph. All right, good enough, right? And then same, second calc, go down to integral of f of x. Lower limit was 0.5, upper limit 1.2. 0.119. Finish.
And
Done.
it would always be the X. And not
E-
the Y.
The lower limit and upper limit are x limits, yeah. It's saying from where, this is lower, this is upper.
Okay.
Or you could do geometry, just do the geometry. It's easy enough, right? So if I needed to do a trapezoid from, let me take a new page because I'd rather be clear. So here, and I want to go from 0 to some value which I didn't bother to calculate, and I want to go from 1/2 to 1.2. I want this area. So it's a trapezoid. So this one is x over 5, right? So 0.5 over 5 is the height. I'm plugging into the function y equals x over 5. So 0.5 over 5, which is 0.1. And then this thing is 1.2 over 5. So the area of a trap is equal to base 1 plus base 2 over 2 times height. So base 1 is 0.1 plus base 2 is 1.2 over 5 divided by 2 times the height. The height is the distance from 0.5 to 1.2, 0.7. So this is a trapezoid on its side, right? So 0.7. So what do I have here? 0.1 plus 0.6. No, 0.6. 0.06. 0.06 divided by 2 times 0.7. So 0.16 over 2 times 0.7, which is 0.08 times 0.7, which is 0.56, 0.056, 1, 2, 3, 0.056. And what's the answer? What did it say the answer was? Did I even do it? Let's see. Second calc, integral from f of x, lower limit equals 0.5, upper limit equals 1.2. The answer is 0.119. So clearly I'm doing something wrong, right? Base 1 plus base 2 over 2 times height. Base 1 equals 0.1/2 divided by 5. 0.5 divided by 5 is 0.1 plus 1.2 divided by 5 divided by 2. Base 1 plus base 2 over 2 times the height, 0.7. So 0.1 plus 0.6. That's my mistake right there.
Should have 0.24.
This should be a 0.6. Oh yeah, what am I doing? 1.2 over 5 is 12 over 50 equals 0.24. Sorry, 0.24. So 0.34 over 2 times 0.7. So 0.17 times 0.7. 7 7s are 49, carry 4, 7 7, 8, 9, 10, 11. 1, 2, 3. 0.119. Thank you. So you could do that, or you could use a calculator, or you could integrate. So if you were integrating, you would go like this. Integral from 0.5 to 1.2 of x over 5 dx. which is equal to x squared over 10 from 0.5 to 1.2. So 1.2 square over 10 minus 0.5 square over 10. So 1.2 square minus 0.5 square divided by 10, 0.119. You could do that too. So that's the first thing we started with. So you should have at least one question like that. And then we moved on to the normal distribution. X normal mu comma sigma squared. So it'll give you some number like this. X is normal, mean 100, sigma square 16. So that looks like this. This sigma is 4, so 4, 4, 4, and 4, and 4, and another 4. And let's say the first question says, find the probability that x is greater than 106. So how do you do? How should I do this problem? Yeah. So z equals x minus mu over sigma, right? I'm using this one because this guy is an x. This is an x. X equals x greater than 106. So because it's about x, I'm using the z equal x minus mu over sigma. So this is probability z greater than 106 minus the mean over sigma 4. So probability z greater than 6 over 4. Probability z greater than 1.5. So we go to 1.5 on the z. And I'm interested in this. But the table will give me this. So do you have your z tables with you? Can you tell me what the z table says for 1.50? Point 9336? 9332. So then this part is going to be 1 minus 0.9332. That's your answer. Or you could skip it and just do the calculator command. Norm CDF, left endpoint 106, right endpoint infinity. Mu equals 100, sigma equals 4. Just plain sigma, because the question is regarding x. The question was regarding x, so I used this formula. Z equals x minus mu over sigma. Get it? Next question. So it's part A. Part B, find the probability that a sample of size 4, let's take a different size because the sigma is 4. Sample of size 9 has a mean less than 106. Sample of size 9. So we use step 2, the step that comes right before the central limit theorem, which says if x is normal, then x bar is always normal. X bar is always normal if x is normal. So x bar 9, because it's saying a sample. So it needs to say the mean of a sample of size 9. Oh, I said mean right here. Okay. Is less than 106. So X bar 9 less than 106. Probability Z less than 106 minus the mean divided by sigma over, so 4 over rad 9. So here I'm using Z equal X bar minus mu over sigma over rad N, because this question is regarding X bar. Are you with me? Yes? So I get probability Z less than 6 over 4 times 3. So 18 over 4. Probability Z less than 18 over 4. So 4 4s are 16 and a half. 4 and a half. Z less than 4 and a half. So 4 and a half standard deviations from the mean. The answer is 0.9999. So you could do that, or you could skip all of this and just go norm CDF. Left is minus infinity. Right is 106. Mu is 100. And sigma is 4 over 3. So can you plug this in and tell me what you got? This is sigma over rad N, because the question is regarding xbar. What do you see on your calculator? Let me do it. Second distribution, norm CDF, minus infinity, comma, 106, comma, 100, comma, 1.3333. 0.9999, just as we thought. Get it? Yeah.
How did you know the 0.999 was going to be calculated? How did you solve it?
Because it's 4 standard deviations to the right of the mean.
So you just go like,
So 3 standard deviations to the right of the mean is already 0.999. So I'm saying it's 1. 100% probability. Question? Yeah.
So you know that it's an xbar question and it gives you
When it gives you what?
like the number.
It gives me a mean of a sample of size 9. That's how I know. So the mean says I want X bar, and this is telling me sample size 9. As soon as I say mean of a sample, then I know it's X bar. Okay, question. So that was page 4. Okay, then we talked about the same thing. X is normal 116. The question says, find the cutoff for the top 10% of this distribution. Like this, right? Mean is 100, and I want the top 10%. This is X. So I can't do this problem by hand unless I put it in terms of Z. Then I go to my T table, and I look up the 0.10 column and the last row, Z, right? Can you do it? T table.
how do you know it's T-table and not Z?
Because T table deals with area in the tail. So 1.282, right? So then 1.282, which is Z, equals X minus mu over sigma. Sigma is 4, right? Right? Right or no?
I don't get why we're finding the C-score. Like, how would you know that was the question?
So the only table I have available to me is Z or T. And T deals with area in the tail. So I might as well go straight there, right? Which is what I did. So this tells me that Z.10 is 1.282. And then the only thing that remains to be done is convert this back to X. So X equals what? I'm going to cross multiply. 1.282 times 4 plus 100 equals X. So 5.128, 105.128 equals X. Equals X. Get it? Or just go to inverse norm. Inverse norm, a percentile is 90%, because that's what lies on the left side. Mu is 100, and sigma is 4. So let's do it. Second distribution, inverse norm. 0.9, 100, 4. 105.126. I got 105.128. No problem there. Yeah.
How did you know to put, like, why would we put 0.90 instead of
Because it takes a percentile. So if you want 10% in the right tail, that's the 90th percentile, P90. Get it? If that was asking for the 10% in the left tail, then I would have had to make this 1.282 negative. But in the calculator, you would put in, here, let me do it, okay? Find the cutoff for the bottom 20% for this distribution. So I'm here. So I go to the T table, I look up the 0.2 column and Z. So 0.842 or something? Can you look it up for me, please? 0.842. So my point being, this better be minus 0.842, right? So minus 0.842, because it's to the left of 0, this is 0 under Z, equals X minus E over sigma. Cross multiply and solve. So minus 0.842 times 4 plus 96.632. Or you just take the easy way. Inverse norm, percentile is 0.2, mu is 100, and sigma is 4. Let's do it. Second distribution, inverse norm, 0.2 comma 100 comma 4. 96.63. I got 632, 634. Follow me? Okay, so we did that. Then the next question is, what is Z.2? So Z.2 is the value such that 0.2 is the area in the right tail. So this is Z.2. 0.2. So this would be 0.842. 0.2 is the area in the right tail. That's how this is defined. Z alpha is defined such that alpha is the area in the right tail. Get it? Yeah? So one of the questions will just be really basic like that. Find Z.05. What's the answer? You tell me.
1.645.
Yeah. Z.2 minus Z.2. What's minus of Z.2? That's talking about this. So the answer is minus 0.842. Get it? Do you have any questions? Okay, let's see what came after that. I think it was central limit theorem. Central limit theorem says that start with any x, any distribution x. If you take large samples, n greater than or equal to 30, then x bar will be roughly normal with the same mean mu and sigma x bar, sigma x over rad n. That's called the standard error. Remember that? So it's saying it's going to be roughly normal. So what if I say x is some distribution, the mean is 100 and sigma is equal to 2. Find the probability that x bar less than 102, and it's given that n is equal to 49. So probability z less than 102 minus 100 over sigma over rad 49, which is 7. So probability z less than 2 over 2 times 7. Probability z less than 7 is 1. Finish. Right? So it's allowing me to do norm CDF basically on something because the sample size was big. So x bar is roughly normal. And I can go do this z equals x bar minus k over sigma over rad n. I can go do that. Follow me? I haven't said anything smart. Yeah.
You asked me when you did PZ less than 2.7 over 2, what's that one there? That's the answer.
Yeah, it's the answer because 7 is out here.
Beyond 3 standard deviations, we should just put 1.
0.999, yeah, like that. Question? Okay.
Wait, where did the 2% come?
102 minus the mean over sigma over rad n. So then the next kind of question is, what happens to the standard error if the n, let's create some example. So the question says n used to be 50, n old, and n new is now 600. So what happens to the standard error? So there's a formula that says that new standard error, this should go on your cheat sheet, okay? You have a 3x5 cheat sheet, right? Which is about this big. Right?
Use the back and front.
Yes. It's about that big, I think. Here, 1, 2, 3. 1, 2, 3, 4. It's about right. Okay, so the new standard error is equal to radical old n over new n times old standard error. So this formula should go on your cheat sheet. So you just plug in like this. Radical old n, 50. Radical new n, 600. Cancel the 0. Times old, sigma x bar. So rad 112 times the old standard error. So it's saying that if you make your n 12 times as big, then the standard error will be radical 112 times the old standard error.
And we put the words old standard error, there's no other number assigned to it.
It is multiple choice. Question? So it's 1 over rad 4, rad 3. So it's 1 over 2 rad 3 times the old standard error. Right? Are you guys understanding me?
So radical 112 wouldn't be in a decimal?
As however it is, you're going to have to make your answer to pick a choice.
Okay.
That's why I'm showing you all different variations of what it could be. If you don't see 112 there, don't freak out. You're going to have to play with it, is what I'm saying.
Okay.
So next thing after standard error was confidence intervals. So a 1 minus alpha ci for mu is given by x bar n plus or minus z alpha over 2 sigma over rad n. This part is called the E, which is the margin of sampling error. So the length of the confidence interval is E plus E, which is 2E. Right? So the kind of question they can ask is that you want the E contained. I want the E to remain less than 0.1. S is given to be 0.6. Find the minimum N necessary to keep the error bounded. And let's say either this can say E less than 0.1 or it can say L less than 0.2. So L is equal to 2E. So I immediately divide this, right? So if they tell me that L has to be less than 0.2, right? It means that 2E has to be less than 0.2, so E has to be less than 0.1. Follow me or no? Given that L is less than 0.2, that means that E is less than 0.1. Okay, so this is what you do. They better give you a confidence level. So confidence level equals 80%, let's say. So it looks like this, right? 80% lies here, 20% left to be shared between two tails, so 0.1, 0.1, 1.282 and minus 1.282 from the T table, last row. So put on your cheat sheet that when N is unknown, you always use Z, even if they give you sigma, even if they give you S. Whether they give you S or sigma, you always use Z because you can't use T because the N is unknown and therefore the N minus 1 is unknown. So you don't know what row to go to in the T table. So you should go to the last row. So last row. So 0.1, which I got from here, equals Z alpha over 2, which is that. Sigma or S is 0.6 over rad n. And my job is to solve for rad n. So rad n is equal to 1.282 times 0.6 divided by 0.1. So this goes into the 6 times. Therefore, 1.282 times 6, 7.692. But I don't want that. I want the square of it. So square that guy. 59.166. N equals 59.166. So non-integers don't work because it's a sample size. Round up to 16. Get it? Question? All this is in your notes. I'm just doing a recap. Yes.
What's the significance of alpha?
So alpha is the type 1 error. So you're looking for the 1 minus alpha CI. So your 1 minus alpha is 0.8. Is that what you mean? Or you want more? Or
I got it.
so alpha is type 1 error, and alpha has to match, the alpha from the hypothesis test has to match the symmetric confidence interval level. They have to both add up to 100%. So they might give you this number, or they might tell you that alpha is 0.2. Either way, you're going to do the 80% CI for mu. So alpha helps you, this is alpha over 2, and it helps you find the Z alpha over 2, which is the critical value. Follow me. Is that enough for you, or do you want something deeper?
That's all right.
Is it fine?
Yeah.
Okay, yeah.
I just always missed something. How do you know when to use like x bar minus mu over standard deviation divided by square root of n? Or like one we just used now, where we didn't, it wasn't square root of n. It wasn't standard deviation, it was square root of n. I don't know how to use those two different formulas.
There are 3 formulas that you're mixing up, right? So let me
I have
explain.
a regular z one, like that's just it. I don't know what to use.
So if it's x, you use z equals x minus mu over sigma. If it's x bar, you use z equals x bar minus mu over sigma over rad n. And if it's find n where E is given or L is given, then you go E equals Z alpha over 2 sigma over rad n.
Okay.
It's always Z, and this could be sigma or S. Okay?
Use the open.
Yeah.
How do you know when the question is asking about X bar? And is X bar the sample size of ones, or
X bar is the mean of a sample of size n.
does N have to be greater than 30, or it doesn't matter?
If X is normal, X bar is always normal. If X is not normal, then n has to be large, where large is defined to be minimum 30 for X bar to be normal, roughly normal. So if n is small, X better be normal for you to be using parametric methods for X bar.
So if X is small,
I confused you more? Okay, let's say that n is 4. If X is normal, X bar is normal. I don't care what n is. If X is normal, X bar is always normal. If n is 40, X could be anything, and X bar is normal, roughly normal.
so how do you know X bar is normal and X is anything?
You have to check to see if n is greater than 30.
So when n is greater than 30, x could be anything, and when n is greater than 30, x bar could be normal? Is normal?
If n is greater than 30, that means you're taking large samples. You can start with a population that looks like this. And x bar will still look like that. If n is greater than 30, greater than or equal to 30, then x bar is roughly normal no matter what x is. So it allows you to do norm CDF as long as your n is large. Don't worry, I won't trick you and give you a small n and a non-normal x. I will not do that. Okay. So then, confit interval, then there's the t distribution, right? So how do you know if you use z or t? Z or t. So if they give you sigma, you use z. If they give you s, you use t with n minus 1 degrees of freedom. So there's another confidence interval formula, right? X bar n plus or minus t alpha over 2s over n. Again, that's called E, right? Then there's hypothesis testing, right? Oh, then there's also how do you use a confidence interval to draw conclusions about a hypothesis test, right? Something like this. Let's do it. H naught mu equals 10 versus HA mu not equal to 10. What side is this test? Yeah, two-sided test. As soon as a test is two-sided, you can use a confidence interval for a conclusion. So let's say that alpha for this problem is 0.20. This implies that I will find the 80% CI for mu. 80% CI for mu. Stick the 80 in there. Say that, want to complicate things a little. So S is given to be 4. So they gave me S, so I'm going to do T and minus 1 degrees of freedom. So let's say that N is 28. So T, 27 degrees of freedom. Agree? Okay, so can you go to your T table and look up 27 degrees of freedom and 0.1 because alpha is 0.20. (1.314) minus 1.314. So what am I trying to do? I'm trying to find a confit interval. So x bar n plus or minus t alpha over 2s over rad n. So x bar is, I don't know, I can make something up. Let's say it's 9.2 plus or minus 1.314 times 4 over rad 28. And I end up with some confit interval, right? Let's do it. 1.314 times 4 divided by rad 28. 0.99. Perfect. Let's just call it 1. So 9.2 minus 1 and 9.2 plus 1. So this is 8.2 and 10.2. And guess what? They're trying to test mu naught equals 10. This thing is 10 right here. So all I want to do is see if 10 falls in here or not. So 10 falls within. Mu naught equals 10 falls within the confidence interval. Therefore, do not reject H naught. We did a whole bunch of problems like that, right? So let's take another scenario. Let's say that it looks like this. the 95% confidence interval for mu is given by 16 comma 18, and I'm testing H naught mu equals 14. Like that. So you just have to go and drop this number. 14 falls here. This is mu naught. And the whole confit interval is larger. So reject H naught in favor of HA. And then furthermore, the whole confidence interval is greater than 14. Therefore, conclude that mu is greater than 14. Right? Yeah.
What would you do if the degrees of freedom is 119? Would we keep it with 60 or 120?
60.
60.
Okay. Then we did the critical value method for performing a hypothesis test. And all this stuff you can do in your calculator, right? Let's write the calculator commands. Stat, test, Z interval, or T interval. This one if they give you S, this one if they give you sigma. Okay. Next is the critical value method, which says, I make something up, H naught equals 5 versus HA mu less than 5. This is a left-sided test. That means the critical region's on the left side. Let's say that alpha is 0.01. I put the whole alpha in the left tail. And let's say that it's a t-test. So t with 6 degrees of freedom. N was 7. Therefore, it's t with 6. First, find the critical value. Can you get me one critical value from your t-table? 2.998. If you forget the minus, it's going to be wrong because 2.998 will also be a choice. You don't want to pick it, right? It's left-sided, so it has to be in the left tail, right? So minus 2.998.
Wait, I think it's 3.143.
Oh, 6 degrees of freedom? It is? Okay, so you know what? I'll change this to 8 and I'll change this to 7. How's that? Is that the one for 7 degrees?
Yeah.
Okay, perfect. Then, oh boy, what am I doing? I found the critical value. Then they have to give you an xbar. So xbar 8 equals 4 and S equals 2. So we go T equals x bar minus mu over S over rad n. So x bar is 4 minus 5 over S 2 over rad 8. So it's negative 1 over 2 times rad 8. So radical 8 divided by 2. It's not possible. Radical 8 divided by 2. Okay, so this is rad 4, rad 2 over 2. Why am I getting 2 here? What am I doing wrong? Radical 8 divided by 2. 1.414. That makes sense. Minus 1.414. Okay, so minus 1.414 is called the test statistic, T naught. So you drop that into this picture and it falls here. minus 1.414 equals T naught. So I'm not in the rejection region or critical region. Therefore, do not reject H naught. Does that make sense? The test is not significant. Yeah,
What did we do with the negative 2.998?
I compared this number to that number to see if it falls to the left of it or not. Get it? This whole thing could have been done by doing stat test t-test. Stat test t-test. Let's do it. Stat test t-test. Data or stats? Stats. Mu naught equals 5. X bar equals 4. S equals 2. N equals 8. And the test cited, so please pick the second option. Calculate. Minus 1.4, minus 1.414. So I just go and drop that. Are you with me or no?
Yeah, I always calculate the p-value.
P-value. So P-value is the probability of being more extreme than this. So this is the P-value. So if I were you, I would cheat and go to TCDF, left endpoint minus infinity, right endpoint minus 1.414, degrees of freedom 7. Finish. So second distribution, TCDF, left endpoint minus 100, minus 1.414, degrees of freedom 7. 0.1. P-value is 0.1. Did they say 0.1? Yeah, they gave you the p-value and it was 0.1. So we're good. Yeah,
Is mu naught the same thing as H naught?
mu naught is the mean that comes from the null hypothesis. The mean in the null hypothesis in the claim.
Okay.
Question? Do you feel pretty comfortable? Okay, good. 77 questions, 3 hours. So normally it's 2 hours. Last semester when the kids took it, it was over 2 hours. I'm allowing you an extra hour because it's online and you may not like that. I don't know. It should be enough time if you know what you're doing. What are your questions for me? Yeah. Anyone? Yeah.
I just realized, how do you know to, when we do a reset to not reject, what are we comparing it to?
I'm comparing is one of two things. You can either compare this number T naught to the critical value. So the T naught is minus 1.414, and I'm comparing it to minus 2.998 to see does it fall in the critical region or does it fall in the white region. So it doesn't fall in the critical region. It falls in the do not reject. So my conclusion is do not reject H naught. The test is not significant. Or I could have compared the p-value to alpha. So p equals 0.1 and alpha equals 0.01. So p greater than alpha, do not reject H naught. Get it? They should give you the same conclusion always. which is the same as saying fail to reject H naught. Question? Then there's binomial, right? Let's go there. We just did binomial. Is it fresh in your mind? Okay, I've got 52 trials. Probability of success per trial is 0.1. Therefore, Q is equal to 0.9. Find the mean. N times P. That's the same thing of E of X. That's the mean. So N is 52, P is 0.1, so it's 5.2. That's the mean. Find the sigma. Rad NPQ. It's only good for binomial. So this is rad. N is 52, P is 0.1, Q is 0.9. So whatever it turns out to be, right? I don't care about the number. Next question. Find the probability of 9 successes. So that's probability R equals 9. So that's binomial PDF NP9, where N is 52, P is 0.1. Next question, find the probability at least 9. That's probability 9 or 10 or ... all the way to 52. That's 1 minus probability of 0 all the way to 8. That's 1 minus binomial CDF NP8. You get it, right? Okay, what about at most 9? Let's change it up. At most 11. That's equal to probability R less than or equal to 11, which is binomial CDF and P11. CDF for cumulative. That's the same as probability less than 12. And this is the same as probability more than 8. Right? More than 8 means strictly more than 8, not including 8. Right? You get me, right? Okay, so then the next question is, let's see, 0.09, 10% of would 8 successes be unusual? Would 8 successes be unusual? How do you do it? 8 successes.
See if the probability of 8 or more is less than 1.
How do I know to go 8 or more and not 8 or less?
Okay. You just gotta read the problem.
So here's the problem. I have 52 trials, and they want to know if 8 successes are unusual. So how do I know to go 8 or more rather than 8 or less? Why'd you go 8 or more? Why aren't you going 8 or less? 8 is such a small number, ain't it? No. So you have to find the mean. 8 is what compared to the mean? So 8 is larger than, so you're right. I just wanted you to tell me why. 8 is larger than the mean. So I want to draw a picture on the next page. So here's the mean, which is 5.2, and here's 8. I can only consider if 8 is unusually large because it's larger than the mean. So I want to see this. So find probability x greater than or equal to 8. If that is less than or equal to 5%, then 8 is unusually high. Did you submit your extra credit yet? Yeah? Probability x greater than or equal to 8. How do I do it? How do I compute this probability? 1 minus binomial CDF NP7. Because the probability from 0 to 7 and 8 and all the way to 52, they all add up to 1. So if I'm interested in more, then I have to take this mess away. Take away. So 1 minus binomial CDF NP7. So 52 and P was 0.1. So 1 minus binomial CDF. Okay. 52 comma 0.1 comma 7. 0.144 is not less than 5%. Therefore, nothing unusual about 8 successes. Get it?
That's just the question.
Alpha is 0.05 if it's not provided. So this is my alpha and that's my p-value. Get it? Question? So I think I pretty much covered like 70 questions out of 77. I think you'll be very comfortable if you know what I just did. Are you okay with this? Okay, so there's still office hours tomorrow. And I sent you a whole list of office hours, did I? Yeah. And everybody knows what time they're assigned or no? Yes? Do you guys know what time your assignment is to take the test in Fry 109? Oh, do not forget your ID, because without ID, you cannot take your test in Fry, right? Do not forget your index card and your calculator, and do not bring your cell phone or a watch with you while you're taking the test, right? Because if you go in with a cell phone and you're caught using it, it's a F in the class. It's not worth it, right? And don't try to communicate with your neighbor, because what the testing center does is they have a screen and they are watching you as you're taking your test. So the minute you roll your chair back like this to talk to the guy next to you, they see that you're sticking out, and then they watch you, and it's over after that. It's just not worth it, okay? The security is really tight there. So it's not worth it. It's better to get an 80 than a Q on your transcript. Okay. Yeah, so pack up that cell phone and pack up that watch, because if you're caught with an iWatch or whatever the hell takes pictures, it's done. Yeah.
I was gonna ask, regular watches aren't good.
Just pack it away for the test, right?
Right.
Oh, because you want to know what time it is that it?
Yes.
The computer says the time?
Yeah.
For sure? You
It's at the top too, how much time you have.
But will you see it if your page, you can't get out of there, right?
You can just scroll up to the top. It says like,
Okay, so wear a regular watch like this one.
Oh, yeah, that's what I meant.
I know. I'm putting it under the camera so they can hear me. The other 200 people who are not here. What else? Yeah,
For index card, is it strictly formulas or can you like definitions?
you can put whatever you want. Yeah, the reason why it's such a small card is because people used to write, people would take a photocopy of this, make it this small and write, and that would be their page. So now we only allow this much. Figure you can put what you really need on there. What else? So your final, I might as well tell you now, is 95% the same material, right? I mean, there's no reason why you shouldn't get an A in this class. This exam will replace exam 1 with a penalty of 10 points, right? So if you get a 90 on this, you'll get an 80 on exam 1, unless your exam 1 was better than an 80. If it was better, it'll stay. You know that, I told you this already, right? So like, kill this one and then kill the final and leave with a happy memory of 102. That's it, done, right? So the only new material is the material on normal approximation to the binomial, which is like, it'll take me about 40 minutes to teach you that. And we'll do that after the exams are over. There won't be any 102 classes next week because you're taking exams all week. The following Monday, your class is Monday, Wednesday, right? So the following Monday, we'll go over normal approximation to the binomial. There's nothing more left for me to show you that's on your final after that. Any questions? Yeah.
Is the final going to be like the midterms where we choose whatever time works for us, or is it one strict time?
You will choose your time. Yeah, but it won't be such a vast choice because I think she only gave me few options. I will post that as soon as I have it. Yeah.
So the final is cumulative?
The final is not cumulative. It's only on exam 2 and one more day. So exam 1 material is not on the final. Yeah, you're positioned for success. You just have to do it now. I can't do that part for you, but you're placed there to succeed. The final is short and sweet. No more than, I think 40 questions or something like that. It's short and nice, and it's short. Yeah, hour and a half, you're done. It's on the computer online. Yeah. Could it be less material than exam 2? Could it be? It's already online waiting for you. What, you want less than this material on the final? I cannot. I'm sorry. If it was 110, you would be only tested on the last 2 weeks material, but imagine 30% of your grade or something similar to that being based on all new material. This is much more comforting because empirical rule is going to be like, yeah, 68, 95, 99.7. What could she possibly ask me that I don't know, you know? Whereas all new material is going to be tougher. What else? You're going to do the extra credit, right? You're going to do pretest C. Pretest C and the extra credit and the problem sets A and B, both. Use the calculator by all means. So hypothesis testing questions, just use the calculator. If you do problem B and pretest C and the extra credit, you should be good. Should be good. The solutions to the extra credit will be posted the day after. Some of you will look and some of you won't. What else? Any other questions? Yeah?
How do you find U naught again?
Mu naught comes from H naught. This is mu naught.
Okay.
I'm testing to see if kids start telling time before the age of 5.
Okay.
So 5 and then less than 5.
Okay.
Yeah. Right? Before the age of 5. So I made it left-sided.
Right.
No right, left. Left-sided, right?
Yes.
All right. What else? So if you're stuck and you don't know what side your test is, if you're stuck and you're reading it and it's like, I don't know what side this test is, most of the time when it's left-sided, this number will be less than mu naught, most of the time. It's not the right way to figure it out, but it's a way to get by, right? If it's one-sided.
Okay.
It still could be two-sided, though, right?
Yes.
What else? Anything else? All right, good luck, guys.
I have to do a specific question for the past exams.
Yeah.
It's this one. I'm not sure quite how to find it. I think it's these general ones. Without looking exactly through the Z table.
The area under the standard normal curve to the left is 0.5. So I would do inverse norm 0.5. Yeah. The area under the standard normal curve to its left is 0.9826. Inverse norm 0.9826.
And then for the right is 1 minus inverse norm of that number.
The area under the standard normal curve to its right is that. So first do 1 minus